We've been factoring trinomials. Today we're going to talk about factoring special cases. So I'm hoping that today I can show you maybe some shortcuts so that you don't have to use the 5-step method every time. If you don't recognize the rule or the shortcut, or I've had some people tell me today they did not like the rule or the shortcut, and that's perfectly fine. You are welcome to use the 5-step method, but I want to give you all the tools available to be able to solve problems quickly. You ready? Any paper? Yeah. All right, so the first rule, we're going to be talking about factoring perfect square trinomials. So what I did was I started with kind of the answer. So the first one says a plus b squared. And we're going to work our way backwards to the trinomial. You ready, Robin? All right. So the first perfect square says a plus b squared. So if I work this backwards, I want to kind of zoom in here. If I work this backwards, I could say a plus b times a plus b. Because that's what it means to be squared, right? You multiply something times itself. All right, so let's FOIL this. So a times a is a squared. Good teamwork. A times b is ab, so plus ab. Inside, b times a, ba, or if I wanted to write it in alphabetical order, ab, right? This problem has abs. Sorry, that's off topic. All right, b times b, b squared. Oh, no, no C's in this one. No C's in this one. All right, so what's AB plus AB? Not squared, that's AB times AB. 1AB plus 1AB is 2AB, right? There we go. If I bring down the first and the last terms. So if I have a trinomial that looks like this, Ace. Is that a question for me? Oh, sorry. You can move your desk over if you need to. All right, so if we have something that looks like a squared plus 2ab plus b squared, I can write that as a plus b squared. That's the rule. I know. I'm going to show you all an example here in just a minute. I'm going to show you an example. So right now, all we're doing is some more practice with multiplying. Yeah.
So the problem is its answer?
Yeah, so like if I give you a problem like this, you can factor it into this without any math. And I'm going to show you an example here in just a minute. All right, let's do the second one, you guys. Because
pretty much like the answer is the question. You just factor it out.
Yeah. Yeah, so there would be no work to show, no work to do. That would be it.
That's what I just said.
So like if you have it like that in a piece of text.
All right, hold on.
I don't think this is a good one to teach this class. Just wait.
Hold on. Save your hands to yourself. I'm going to show you one more because there's two different perfect square trinomials. We also have a minus b squared. You ready? So let's try a minus b squared. We're going to multiply this out. So a minus b squared, that's a minus b times a minus b. right? Children. All of you. All right, so this time I'm going to use the box just because I like to change it up. If you like foil, use foil instead. That's fine. We should get the same answer. So I have A minus B, A minus B. So A times A is A squared. A times negative B is negative AB. Beautiful. A times negative B is negative AB. Very nice. Finally, negative B times negative B
Is B squared.
positive B squared. Very nicely done.
Is our next test gonna be open?
It's going to be all like factoring. Our next test is nothing but factoring.
But are
On
we
Friday.
using our notes?
No, but we are reviewing tomorrow. All right.
Damn.
So we've got A squared minus AB plus B squared.
So the whole test, we just have to like factor.
Yes, ma'am.
Like what
All right.
we're doing right now?
Mm-hmm.
Oh.
All right, so I have minus AB. That's going to be minus 2AB.
This is
No. No, well, it would only cancel. It would only cancel, good question, if one was a positive and one was a negative. Remember, like the warm-up?
I think we're done with school.
All right, so here, I can write my factors as A minus B squared. Okay, hold on. Hold on. Because look, that was the problem. That's what we started with. So A minus B squared is A squared minus 2AB plus B squared.
Well,
Hold on. Hold on. I'm going to show you guys with the problem with actual numbers how this would work. Yes, ma'am.
so if like we have it on the test, can we just circle the question?
Let's see. I'm not quite sure what you mean by that. You'd have to show me when we get to it. Okay. So, example number 1. Example number 1. Please stop talking. I've got x squared minus 6x plus 36. Well, no, there's nothing to multiply. We're factoring, we're working backwards. So here, you can use the 5-step method. I'm going to use the rule first because I want you to have exposure to it. But if you do not like the rule, you can use the 5-step method. It will work every time. Okay? Okay, so I'm going to look here. X squared, the square root of x squared is x, right? The square root of 36 is 6. So the middle term, this one here, 2 times A is x times C is 6. What's 2 times x times 6? 12x.
Wait, where'd you get to?
Hold on. I'm using the rule, remember? If I've got a squared minus 2ab plus b squared. Oh, y'all can't see the rule. Hold on. I'm looking to see, does this equation satisfy the rule? Hold on, where's my, there we go. So I've got x squared. So a, the first term, is a perfect square, right? The last term is a perfect square, right? The middle term, minus 2 times a times b. So x times 6 times 2 is 12x. So this is written as a perfect square trinomial. So I can write the factors as x minus 6 squared. I know. Like I said, if you don't like the rule, you can use the 5-step method. But I would want to expose you to the rule.
Yeah.
2 is part of the equation. Right here.
Then how come at the bottom you just put x minus 6?
Because that's the rule, remember? This would equal a minus b squared.
Oh.
Is that better? Sorry. Let's do one more like this. One more like this. Yes, it is. Now let's try one more like this. You ready? You're fine. All right. Example number 2. We're going to factor 4x squared plus 20x plus 25. I thought I gave you a pencil.
I forgot that I had a pen in my hand. In my pocket.
All right, you ready? So this, I want to note, is this in the form ax, sorry, not ax, a squared plus 2ab plus b squared? If it is, I can write the factors as a plus b squared, right? So let's see. My first term is 4x squared. Is that a perfect square? What's the square root of 4? 2. And the square root of x squared? Perfect. All right, so we got the first term. What about the last term? Square root of 25 is 5. Now what about that middle? So 2 times 2x times 5. What's 2 times x times 5? 20 x. Does that match that middle term? Yes. So can I write this as a perfect square trinomial? Yes. So my answer is going to be, what's my first term? 2x plus 5 squared. All right. And the question that I get is, how do you know if this is plus or minus? If these are both positive, like we have here, plus 20x plus 25, then we're going to say plus. If they're not both positive, if we had a minus and a plus, then it would be minus.
This way is for sure shorter than this.
And that's okay. If you prefer the 5-step method, that's fine. Yes, ma'am.
So why is x squared x?
The square root of x squared is x because x times x is x squared.
Bobby.
Just like the square roots.
So why did you do the square root of 4 and then do the square root of x squared separate?
We could have done it separately. It doesn't matter. Whatever way you prefer. All right. That's fine. All right. But I do want to show you guys factoring a difference of 2 squares. This one has been quite popular today. Difference of 2 squares. So last rule. One more rule today.
I write it down.
Okay, making sure you got it. This one I think you might like. This one is a little easier. Okay? So the difference of 2 squares. Xavier, I'm gonna write this one down. We've got a squared minus b squared. This is like the warm-up we did today. Because our first term is a perfect square, our last term is a perfect square. Do we have a middle term? No, so what am I looking for? We've got to add up to be 0, right? Right? We have to add up to be 0. And multiply to be b. So we have to have opposites, right? So like we did in the warm-up, we're going to have a plus b times a minus b. Those are the factors for a squared minus b squared. Bless you. That's the rule. So, if I were to multiply this back out, I want to show you. A times A is A squared, right? A times negative B minus AB, right? Positive B times positive A plus AB, right? B times negative B, negative B squared, right? So now, this time, does negative AB plus AB, do those two cancel?
Yes.
They sure do. So we're left with A squared minus B squared. So A squared minus B squared is
C squared.
A plus B times A minus B. What's that?
I can't see.
Sorry.
I kind of get it.
So let's use this one with a real problem, with real numbers. Well, with actual numbers. We'll always use real numbers, but with actual numbers.
Those are actually. Oh, those aren't real.
They're actual
Huh?
letters.
Huh. All right, y'all ready for example number 3? No? We're still writing. I see a few pencils.
I'm not ready.
You ready for example 3? All right, example number 3. Oh, biscuits. I have z squared minus 9. Hey, this should look kind of familiar. You ready?
I got it.
There you go, there you go. So you got a plus b times a minus b. All right, so example 3, the directions say to factor. So what I'm going to do, I'm going to look at that first term, z squared. Is z squared a perfect square? No? What's the square root of z squared? Z.
Wait, I thought we were doing all this.
Yeah. What about 9? Is 9 a perfect square? What's the square root of 9? 3. So if the first, we have a difference of 2 squares, right? So the rule says I can write my factors as z plus 3 times z minus 3. That's it. Is that okay? Try another one.
What's wrong with the home?
Okay. You can use the 5-step method. It'll take about the same amount of time. I just want you to know what those rules are.
So the simple ones and those are always going to be the.
As long as your first and second term, if it's got 2 terms, if it's a difference and both are perfect squares, that's the rule. Okay?
Well, what I was thinking about for the other ones is that if the answer is going to be the question, why can't you just circle the question?
No. You have to work it out. That's not how it works. All right. Example 4. Nope. Example 4. Eyes up here, please. Lena. Eyes up here, please. Eyes up here, please.
Do you want something?
All right, so I've got 16x squared minus 81. So again, I have a difference. As long as these are both perfect squares, I can write this as the difference of 2 squares, right? I mean, this is the difference of 2 squares, so I can write the factors. Sorry, I said that backwards. All right, so let's see here. I've got 16x squared. So what's the square root of 16? 4, and the square root of x squared is x. Very nice. What about the square root of 81? 9. So I can write this as 4x plus 9, 4x minus 9.
It always seems like this way is too simple.
Good. One more like this. Just one more.
Just the
x. The square root of x squared is x, always. Yes. Because the rule says the difference of two squares, right? The rule says the difference of two squares.
So even if this was plus 81, it's
Then we wouldn't be able to factor it. If it were plus, we wouldn't be able to factor it.
so then what do we do?
It would not factor. All right, last example. You ready? 24g squared minus 6. 24g squared minus 6. All right. So I see some of you already looking, typing in your calculator square root of 24. That's not a perfect square, is it? So what I'm going to do, look. Do 24 and 6 have any common factors? 6, right? 6 goes into both? So let's factor out 6 first. So I have 6. 6 times what is 24? 4. So 4g squared minus 6 times what is 6? 1. Right?
Yeah.
Is that okay?
Yeah.
All right, so now that's my first and second term. So is 4g squared a perfect square? No. Yes, what's the square root of 4? 2. And the square root of g squared is g. And what's the square root of 1? 1. Right? So then I can write this as 6 times 2g plus 1 times 2g minus 1. All right, let's practice.